Hello everyone. Here is a problem which can be solved by application of trigonometry. Let me read out the problem to you first. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. So we have a kite here, right? There is a kite which is flying above, and it said that the kite is 60 meters above the ground. So let me draw a perpendicular from the ground. So this is the ground, right? Let me draw the ground here. Okay, I need a line. So this is the line which represents the ground, and the kite is at a 60 meters distance from the ground. So this line here stands for 60 meters. I'll have to increase it a little. Okay, fine. This stands for 60 meters. The length of this is 60 meters, and the string attached to this kite, so let's assume that the string is attached somewhere here. It is tied to a point on the ground. If we say that this is the point on the ground where the string is tied, and it is tied in such a way that there is no slack in the string, this is being assumed that the string is taut. Only then we can find the length of the string, right? So this is the string which is being tied to the ground, and the other end of the string is attached to the kite, and the inclination of the string with the ground is 60 degrees. This is given to be 60 degrees, right? Inclination of the string with the ground is 60 degrees. We'll have to find the length of this string. So let this be x. How do we go about this? We have a 60 degree angle here, and we know the opposite side of 60 degrees, right? We know this side, the opposite side. Now we are going on the assumption that this is a right angle triangle. Of course, it's evident, it's obvious that it's a right angle triangle, because these two lines are perpendicular to one another. The ground and the height of the kite is perpendicular to one another, and the third side is the hypotenuse of this right angle triangle, and we'll have to find the length of the hypotenuse. The length of the hypotenuse has to be found. Now, which is the trigonometric ratios which involves the opposite and the hypotenuse? Can it be sine? Yeah, sine of 60 degrees, or sine of any angle actually, is equal to the length of the opposite side of 60 degrees by the hypotenuse, right? And what is the trigonometric ratio sine 60 degrees? Sine is here and 60 is here. It is root 3 by 2, right? We have done these in our math decoded. We have derived all these, and please go and refer to it if there is any doubts regarding that. So this is equal to root 3 by 2. Sine 60 is root 3 by 2, and its opposite by hypotenuse. So we can say that 60 by x is equal to root 3 by 2, or this implies that root 3x is equal to, I'm sorry, I should have written root 3x, right? So let me write that properly. Root 3x is equal to 60 into 2, or x is equal to 60 can be written as 6 into 10, or 3 into 2 into 10 multiplied by 2 by root 3. Why did I split up 60 and write it as 3 into 2 into 10? Because I just needed a 3 in the numerator, so that I can expand the 3 and write it as root 3 by root 3. And 1 root 3 can be divided. Both numerator and denominator can be divided by root 3. So ultimately I get this, right? We just get a 4 into 10, 40, and a root 3. So now we can say that the length of the string this length of the string, which is assumed to be x, is equal to length of the string is equal to root 3 or 40 root 3, right? 2 into 2, 4 into 10, 40 root 3, and it is in meters. So we obtained the length of the string using applying trigonometry, especially sine of 60 degrees. I hope you followed this problem. Thank you.